In the last class, we had discussed about the introduction to Android as a software stack, and then we had seen the different versions and a little bit of history, and then we saw where and all Android is working, where and all it runs, and what is the advantage and what are the features and all those things we wound up in the last class. Okay, in this class, I'm going to go a little bit technical details of that same Android software stack. Okay, so we are going to see what is the architecture of Android. Now, the basic question people would ask is, should we learn the architecture of Android? Is it compulsory to know? Is it required to learn all these things? Okay, when you get into depth of programming, okay, when you go to that level of understanding how an application works, then the development of the application becomes easier is what I believe. All right, so I leave it to you guys, but this is basically in your syllabus and it is kind of theory right now. Okay, but then there is nothing called theory in Android, but rather you'll apply it somewhere or the other. Now, the architecture of Android is something like that. Okay, so let me get into this structure and let's see how Android is structured for you guys to develop. Okay, so let me begin with that in this class. Okay, so the architecture. First of all, Android is a multi-processing system. All right, that I guess all of you know already. Okay, almost all operating systems are multiprocessors. Okay, so that's not something new, but Android, why is it specifically mentioned here? Because it is a mobile operating system, not a regular operating system, but rather it is working as a mobile operating system. So a multiprocessing system inside a mobile screen or inside a mobile phone is kind of an achievement. Okay, let me move on. Each application runs on top of the Android Dalvik virtual machine. Okay, I'll explain that shortly, but please remember each application runs on top of a keyword. Okay, let me keep that keyword aside for a minute. I'll explain a little bit more detail later. Okay, each machine, that word which we have used, the virtual machine, what I've used, runs on top of a Linux process. Okay, basically the operating system which is running behind in Android is Linux. Okay, or some people might use the word Unix. Okay, but we prefer to use the word Linux trolls. Okay, so let's keep this in mind. Basically, the operating system which you see on your phone is a Linux operating system. I can also tell the same with iOS. Okay, iOS is also based on a Linux kernel. All right, but then they have their hardware attached to their software. All right, but us as Android developers, the architecture what you're learning right now is same. Okay, you can apply it on an HTC phone or an MI phone or a Samsung phone, doesn't matter. Okay, so this is a system architecture what we are discussing right now. So please note every app, okay, they've used the word application, but you understand that we normally we call it as app because it's a short form of an application. All right, so every app what you are working runs on a virtual machine, and each virtual machine runs on top of a Linux process. Okay, so what is at the core of your operating system? Linux. Remember that. Okay, each process runs in its own sandbox. That's just a keyword for you to remember. Okay, I'll explain that shortly how it works and all. Okay, which means it can access only the resources it creates. Okay, I'll explain this shortly, but this is just an overview of what we are going to see. All right. So to access resources outside the application sandbox, the app needs to request permission. Okay, these are words which we have put with respect to the architecture. All right, nothing is new to you guys. You already knew all these things, right? See, when, for example, if WhatsApp wants to access your contacts, okay, WhatsApp is in a different sandbox, or let's not use a sandbox. Let's say that it has its own house. Okay, and we have contacts, which is also an app in your phone, which is also running like a house. Okay, it has a house. So two different houses or two different apartments are there. Okay, so if you want to request a chair or a table from one apartment, okay, you'll have to request. You cannot just go barge in and take it because it's in a different location. All right, so it doesn't belong to you. So you'll have to request permission. All right, that's what we see how your Android system works, is that each app or application which runs in your phone is running on a virtual machine. It's called as a Dalvik virtual machine, and each Dalvik virtual machine runs on top of a Linux process. Okay, each process runs in its own sandbox. Okay, when you say sandbox, most of you would have seen this in antiviruses. Okay, what is a sandbox? Or some people use the word quarantine. Now it's become very famous for us. It is just isolation. Okay, so everything runs in its own sandbox. Why do we put people into quarantine? Why do we put people into these isolation wards? Is because they should not affect anything which is outside. Okay, same idea in Android, but they use the word sandbox just for your understanding. Okay, it's just something which says quarantine. All right, so that's the idea. Let me go into the diagram. Okay, this is the important diagram, guys. I think this will be asked for your theory subject also. All right, so this is theoretically a very important question, the architecture of Android. Now, even though the diagram looks big, but there are only few words there. I want you to notice the words first, then the sub keywords. The most important keywords, first look at the topmost and then look at the bottommost. Okay, I want you guys to first understand the topmost and the bottommost. I hope you guys can see this. Yes. All right, what is the topmost one? Okay, just read what and all is inside. You will have an idea. Do not look at the other ones immediately. First look at the topmost. That's very simple. What are those? Home, the home button on your phone, contacts app in your phone, the dial or the phone calling app on your phone, the browser in your phone, etc. etc. To keep it simple, all these are apps on your phone. Can I keep it like that? Okay, they use the word applications, but we use the word apps to understand that they are smaller version of an application. They are not a full-fledged application, but they are apps. Okay, they are a small version. Okay, of your the larger version which is running on your desktop. Okay, so we have apps that I think everybody has used. So we all are familiar with the topmost layer. Now I also wanted to go to the bottommost layer and see what is written there. Okay, at the bottommost in your Android operating system, finally, it is not Android which is the operating system, it is Linux which is the operating system because it is Linux kernel. Okay, you can see that at the bottom you have the operating system. The actual operating system is Linux. Okay, which interacts with the hardware. I hope you guys know how a software works, how a hardware works. Okay, I guess you guys would have already understood what is an operating system, what is a system software, what is a application software. These are all are basics. I think you already should know all these things. But anyway, when it comes to an operating system, what is the work of an operating system? It is just to be a bridge between the hardware and the software. Okay, the user, you have to interact with the hardware. For example, if you have a good graphics card in your laptop, or if you have a Wi-Fi driver in your laptop, okay, you have the best hard disk, best RAM, all those things, but if you don't have an operating system, all those hardware are useless because you cannot interact with the hardware directly. You interact with the hardware through the operating system. All right, so at the bottommost level you can see there is called Linux kernel. There are some keywords inside that also, but majority of the keywords have one word associated with them called driver. Okay, you can see display driver, keypad driver, camera driver, Wi-Fi driver, okay, your flash memory, your memory card driver, audio driver, okay, like that. Lot of drivers are involved in operating system. Probably that's what we do, right? When you install an operating system, you also have to install the driver for audio, you have to install the driver for the graphics card which you have. In case you take Wi-Fi, you have to install Wi-Fi driver. Okay, what is this driver doing? Driver is a system software which acts as a bridge between the hardware, the actual hardware, and the software of your operating system. I hope this is clear to you guys, right? So this is Linux kernel at the bottommost, guys. Okay, topmost you have your apps, bottommost it's working on a Linux machine. Your phones, each phone of yours is a Linux machine. Please remember that. First thing. All right, next thing. Okay, let's go to the gold part where you see, I think I'm moving my mouse. I don't know whether you're able to see, but you can see this part. There is a small block which is light golden color. Okay, you have Android runtime. Okay, then you have another word which is written below, Dalvik virtual machine. Okay, let me ignore the libraries and all those things for now, but just focus on the keywords here. Applications. Okay, I'll just go through the simple flow. Each application runs using a particular framework of that application. All right, I'll talk about frameworks and stuff a little bit later, but I want to keep it as simple as possible so that the diagram does not become too complicated for us. Okay, each app which you have is dependent on one or the other application framework which is available within Android. Okay, even though the operating system is Linux, we do not call it as Linux, rather we call it as Android because it is the software stack. I hope you remember that's the first thing which I told you. Okay, it's a stack of software working together, including a runtime. All these things together we call it as Android. Okay, if you say only operating system, it is Linux. Okay, let me move on. So applications, every application what you have works with a manager or a framework, okay, which controls everything. We have application framework. And then each application runs on a virtual machine. And each virtual machine runs on a Linux process. I hope you follow. Okay, the same thing which I told in the first slide is also put into this diagram. The bigger word is very important for us. Application, application framework, Android runtime. And you see in the same line you have something called libraries. Okay, so this part what you see here, sorry. Okay, this part what you guys see here belongs to Java. Java provides all these libraries. Okay, or whichever language you are utilizing, Kotlin or Java, whatever it is. Okay, that language will provide this particular part of libraries. Whatever features you have in Java will also be attached to Android using this layer, libraries. Okay, and then you have core libraries which are part of your language, the programming language, and then your virtual machine. Okay, this is the architecture, guys. Okay, so keywords which you need to focus on is apps, application frameworks, applications, application framework, libraries, Android runtime, Linux kernel. Okay, the keywords which are there below them, okay, you can remember one or two for that sake and then put it in your diagram when you draw it. Okay, which is very, very important for you to explain. Okay, draw the diagram properly, then you can explain it whatever you have understood with this diagram. Okay, this is the system architecture. Let me go through each and every layer in this architecture shortly. Okay. All right. I think you guys already know this, so I'll not take much time. I'll just quickly go through these things. Okay, so first thing is that Linux kernel. Okay, we are going from the bottommost. Okay, but anyway, please remember Android relies on Linux. Depends on which operating system is running in your phone. Okay, it starts with 2.6 point something till 3 point something something. Okay, for core. Basic operating system which is given in your phone is Linux. Android relies entirely on Linux for that. Okay, and Linux kernel will provide you the operating system services. Okay, what do you mean by operating system services? Basic ones which are displayed. I've just put a few things there. Starting with works as HAL. I think most of you already know, hardware abstraction layer. What do you mean by that? It hides the complexity of using a hardware. All right, now you guys already know when it comes to the hardware part of it. Okay, so let's say that if you buy a new graphics card to your laptop, to your desktop, okay, or if you add a new hardware to your system, PC, okay, it will not automatically start working. And you cannot directly go and access, or you cannot write anything into it or read anything from it unless you have a driver and you have an operating system which helps you do that. Okay, so the complexity of talking to that hardware and programming that hardware, like for example a graphics card or a Wi-Fi card or something like that, okay, that is abstracted, which means it is hidden from you. Okay, operating system normally works as a hardware abstraction layer. Okay, and then it takes care of all the device drivers. All hardware in your system, your phone or your laptop, is managed by the operating system. Please remember that. And next one, memory management. Okay, please remember whenever you use the keyword called memory in operating system or software field, we do not mean your pen drive or your hard disk. Okay, it is not that which we manage. Okay, this memory management always indicates your RAM. Please remember, whenever I say memory management, I talk about the RAM, not about your memory card or the inbuilt memory which is available, or your hard disk or your pen drive. All those things are not. Those are called storage devices. Okay, that's storage management. That's not memory management. I hope you follow. There is a different keyword involved here, but be very careful of that. Whenever I say something is loaded onto memory, I don't mean it's been copied to the pen drive. No, that's not what I'm trying to tell you. When I say something is loaded onto, when you create int a equal to 10, a is loaded onto memory, and then the value of 10 is put into the value 10, which is put inside that value, the name called a. Okay, when I say that memory, I mean the RAM, not your hard disk. Okay, please remember that. Memory management, process management. Okay, most of you would have already done this. You would have gone to task manager in your Windows and you would have killed some processes which are not responding. Okay, if you notice, the next time you open task manager, Okay, the first tab is called processes. What are processes? All the applications which are running in your system right now are processes. You have opened a Chrome or you have opened Google Meet in your phone. All these are processes running on through a RAM. Okay, if the RAM is not there, your system will not start. Okay, you will not be able to proceed into this operating system because most of the services are supposed to be loaded onto memory. Okay, so memory management, process management, networking, okay, and then security. All these are part of the Linux. Okay, which means the operating system should provide all these services, which are already written by Linux people. Only thing Android people did was to port it to a mobile device. Okay, please remember that. So that's the first part of your architecture. The next part, I've already discussed this in the previous one, which I use the word called sandbox. Okay, I don't know how many of you have watched the movie called Emoji. Uh, is there anyone who watched that movie, Emoji? Anyone? Nobody watched that movie? Watched so many movies? Yes, okay, only one. Out of this big class, only one person watched it. Okay, there are few people. Okay, fine. Um, all right. I just asked this question because I don't know whether some people have watched it, some people have not watched it. Okay, in that movie, they depict how an app looks like. Okay, that's something which you need to understand. That's the same logic. Okay, they tell something that is about creativity, but then if you notice in that movie, each app is a building. Each app acts like a building. All right, I hope you guys follow. Same thing is the truth. Okay, each app lives in its own building. If you can remember this, guys, most of my explanations would make sense. Okay, with respect to the program as well as the code which we write. Okay, each app lives in its own building. That's something which you need to understand. That movie has shown that very neatly, but that is, they have a lot of creativity involved in it, but still, the only thing which I wanted to take from that is to understand that every app lives in its own building. Okay, that building's name, we use the word sandbox. Okay, why do we use the word sandbox, and what does it help you to do? Okay, I'll explain that shortly when I compare Java's virtual machine with Android's virtual machine. Okay, so here you guys just look at it. All right, I'll not take in depth of it, but just look at this. There is an application ID. Okay, and there is a Linux user ID, and then there is something called resources. Okay, so you have Linux user ID, and in that sandbox you have an application, and in that application uses some resources. Okay, and what are the resources which are mentioned below? All right, so these are two apps. Okay, let's take two apps in the sense, one is like contacts app, one is like the SMS app or something like that. When there are two applications, each application runs in its own building. All right, but if I open my SMS app and I see who sent the SMS, basically SMS app only has the number, but you see the name, who sent it. All right, how do I see? Even WhatsApp, the same thing. You store your contacts in your phone, but when I open WhatsApp and check my contacts list, okay, I can see whoever has messaged me. For example, imagine if I message you guys. Most of you do not wouldn't have saved my number, but when I try to message you guys, you will get my number. I won't get my name on the screen, right? Okay, because that's a new contact which is messaging you. You see a number, and once you know the person, you click on add a new contact and you save it as a contact. Please note, when you click on add, it takes you to another app. It is not saved in WhatsApp, rather it is saved in the contacts app. Okay, just an idea. It's stored in the contacts app, but when you finish storing, okay, in the contacts app and you come back to WhatsApp, my name will be written there. Okay, that's because they both have an understanding, but doesn't mean that they are working together. They are still in their same buildings. Only thing WhatsApp has done is it has asked permission from you to access some resources from the previous building. That's all. Okay, so that is what I've depicted here, but it is technical. But I wanted to just focus on the words which is used here. Two applications on different processes. Okay, with different user IDs. Each app also runs in its own sandbox, in its own virtual environment. Okay, I'll explain why it is required and why not we have gone through the old mechanism. Why is it so important in a short while? Okay. System libraries. On top of the Linux, whatever we had seen is the set of libraries, including the Bionic, the Google library. Okay. A media support for audio, graphics, video. Okay. A lightweight database, which is a repository for storage, sharing of application data, etc. etc. Okay. A lot of things are available as system libraries, which means you need not install them. They come along with the operating system. Okay. The support for audio and video is there inbuilt. Okay, those who have installed Linux will know that it is not by default available in any operating system. Opening a video or audio. Okay, just take earlier Windows, not this Windows. Okay, earlier Windows, those who have installed will know that if you want to run an MP3 file, not only Windows, Ubuntu also. If you want to run an MP3 file, you have to install a software. It is not inbuilt support. And earlier systems again, even for Wi-Fi, you need to install a driver. Not automatically driver will come in your Linux or Windows. Okay, but now it is not the same because almost every feature is inbuilt. Okay, all those things are given as core libraries of the programming language, whichever programming language you are using. In our case, it is Java. System libraries. Please remember, what is a library in that case? Okay, I'll not go in depth, but just remember, what is a library? A library is an organized fashion. Okay, for example, you take our library, you go, there is two sections. You have an MBA section, you have a management section. Sorry, you have MBA as well as IT. Okay, so when you go to MBA, you feel, you find books which are related to MBA. Okay, in that one, their order it is classified. In IT, you get all related to IT, which is classified according to our order. Okay, so it is kept in a neat fashion. Why? Because it's easy to pull or retrieve something which you are looking for. Okay, please remember that. That is system libraries. Let's move on. Android runtime, which you saw just above the Linux kernel. Okay, in that thing which I told Dalvik virtual machine. Okay, it provides a consistent virtual environment on which every Android application runs. Every app that you are running on your phone is running in the Dalvik virtual machine. Please remember that. But more important is the second sentence. Each Android application runs in its own process with its own instance of the Dalvik virtual machine. Okay, I want you guys to note and let it sink in. Okay, let you understand this particular thing, this last word which I've said. Each Android application runs in its own process with its own instance of the Dalvik virtual machine. Okay, I'm going to stop here for a minute. Okay, and then ask you a few questions before we move on. You all have studied Java. Okay, I'm not denying that. I want you to just picturize when you learned Java, the first thing they told you. Okay, you would have used. Okay, you would have used some keywords. Okay, the teacher who had taught you would have put this word into your mind, Java virtual machine. Okay, they would have used the word called virtual machine, and you should have questioned why that word is used and what is the advantage of it. So can you guys tell me in the chat window that is it, what is that use of Java virtual machine? What is the advantage of using a Java virtual machine, and what is it first of all? Can you guys respond for that? Voice is breaking. I think it is fixed now. Guys, are you able to hear me? Okay, okay, fine. Don't worry about the network issues. I'm recording the session. I'll be posting it shortly. All right, but as long as possible, you can listen. Otherwise, you can just listen to the recorded video. Not a problem. Okay. Guys, can you guys respond? What is a Java virtual machine? Why do we need it? What is it? Can someone respond? It is used to convert Java bytecode into machine language. Okay. Code compatibility. It is an interpreter. All right. Any other answers, guys? Okay. Now, can I say that all these things are also available in other languages? Why do we need a virtual machine, first of all? Before we proceed, what is the meaning of the word virtual? English meaning of the word virtual. Can't be physically seen or touched. Okay. Exists but cannot see. All right. Not physically existing. All right. Correct. All these that correct. All right. So let me just put it in with not real. That's what you guys are trying to tell. It exists but it is not real. Okay. So when I say a machine which is virtual, okay, what do you mean by a virtual machine? It is going to act like an actual machine to the code what you wrote, but it is not actually going to execute on your machine. Rather, it is going to emulate your machine. Like for example, if you are working on a Linux machine, okay, I'll emulate a Linux machine. If you are working on Windows, I should emulate a Windows machine. And then before running it on the actual operating system, using your actual processor, I will emulate the machine first and then run it on my virtual machine. So why do they did that? Okay, first of all, to give, as you guys told, to give different platforms. Okay, you guys would have downloaded Java. I think you would have downloaded at some point of time, or you would have copied from your friend. Okay, but please try to download Java. Okay, even though you would have learned Java is platform independent, when you go to download Java, they will ask you for which operating system do you want to install Java. They will ask Linux, Windows, Solaris, or iOS, or they'll ask you which operating system do you want to install Java on. Okay, so you might have a question: if Java is platform independent, why are they giving us different setup files? They can give just one setup file, no. But why are they giving different setup files? This is the reason. Okay, the virtual machine which they give along will emulate which operating system you are running on, so that the code what you write will not be changed. The code what you write once will run anywhere in any operating system. Okay, it is because the virtual machine emulates, or it tries to give a virtual, not a real machine, but it tries to be acting like the real machine which you are running the program on. Okay, that is a virtual machine. Now, when it comes to phone, in your phone, also the same thing. Okay, your phone runs on Linux kernel, but the Dalvik virtual machine is not going to be a real machine, because the name already says it is a virtual machine. It is not real. It is a software which emulates your original phone. Okay, and it runs on it, and it runs on its own process in its own instance of the Dalvik virtual machine. Now, there is a word called instance there. I hope you guys have noticed it. Okay, what is another word for instance? What we had discussed. If I say instance of a particular thing, what is that actually? In the technical words which we had seen in the last few classes, object, of course. All right, so once an instance is created, you don't care about the virtual machine class, but rather you'll be focused on that particular object. The app alone, you will not bother about all the apps, rather the one app which you are working on currently. You focus on only on that particular object. Okay, instance. Please remember those words. All right, what is Dalvik? Dalvik is an open source software. It is not a technical word, it is the place name of the author. Okay, it is in Ireland. Okay, so the author name is Dan Bronstein, but it's not his name. It's his village name. Okay, Dalvik. It's not a person's name. Like we have Java virtual machine. It is a programming language. Java is a programming language, and the virtual machine which belongs to it is called JVM, Java virtual machine. Dalvik is not a person's name. It's a place name, but it is not a technical term. It is a place name, but since that person created it, we call it as Dalvik virtual machine, DVM. Okay. Moving on, I'll come back to that shortly. Android includes a set of core libraries, okay, which is also the core libraries of the Java programming languages. Okay, so please remember, it is there are application libraries or programming libraries, then you have core libraries. All right, basic necessity of a programming language, the basic part of a programming language is called as the core library. Then additional libraries are there. I'll give examples when we start working with them. Okay, so it's just remember these keywords. That's enough. All right. What is this Dalvik virtual machine? Number one, it is a process virtual machine. Why do we need DVM when we already had JVM? This is the next question. We had a concept called virtual machine. We already had something called Java virtual machine. Why do we need another virtual machine for Android? Bigger question came. Okay. Then these answers were given. Why do we need Dalvik? Because we needed a process based virtual machine to run on a slow CPU. Okay, please understand the phones which you guys are using right now are not the first Android phones. When Android came for the first time, the processor, the RAM, the memory which is available inside the phone were very, very less. Okay, there were smartphones which had 512 MB RAM. Okay, they had processors which are very, very basic processors, not Snapdragon and Qualcomm, what you guys have right now. We had a very, very minute or not that much fast CPU and small RAMs. Okay, as I told, 128, 256 and all was considered as RAMs which were running. Okay, and an OS with no swap space. Okay, this swap space concept will be understood by people who have installed Ubuntu on their laptops. I don't know how many of you have tried it. Whenever you install Windows, you don't care, you just click on install and you choose a drive and Windows does everything for you. But when it comes to Linux, there are options, but normal people who are installing Ubuntu, they will give one partition for the operating system. There'll be one more partition created called swap space, which acts like the hibernate space for Windows. All right, but then it's not important, but just think there is no much space available to give as swap space for an operating system here in Linux. And also, it is always going to be powered by a battery. A desktop machine, okay, when you created Windows operating system or Linux or iOS, the operating system which we are running on a desktop or a laptop, they are not targeted to always run on battery. But when you develop for a mobile phone, majority of the time they are targeted to run on a battery. I hope you follow. No, normally we connect the cable, the laptop and all, we connect the charger cable and start working. Okay, so since we have a lot of work to do, we won't use a laptop like a mobile phone. Majority of us do not use because our laptop will not stand for long time like a mobile. For example, one day morning if you put, probably till afternoon evening you can continue using your mobile but not laptop. Okay, laptop will not come like that. So majority of the time a phone is powered by a battery, not by the external supply. Okay, please remember that. So all these are limitations or restrictions which I cannot apply, just like how JVM has. I cannot take JVM and put it on a phone and expect it to work, because JVM is targeting Windows or Linux or full-fledged operating systems, not smaller versions. Okay, they have minimum this much RAM, this much processor. They have that target in JVM. But when it comes to DVM, you don't have that target. Okay, because we have very, very limited resource. That is why Dalvik was created, and it is register based. Okay, what is the difference then? There is one more type of virtual machine, which is Java. JVM is stack based. Dalvik is register based. Okay, and this relies on the Linux kernel for threading and low level memory management. Please remember that. Same thing. Virtual machines all does the same thing, but specifically I wanted to target this few points. Also one more point called register based. Okay, I'll not go into the technical details, the computer organization details of it, but just these are theory concepts. Okay, please remember this, guys. Just because they have the word called virtual machine, both are not the same. Okay, some people think JVM is equal to DVM. Okay, some people just give an explanation. JVM is a bigger version, DVM is smaller version of JVM. No, not like that. They are not at all equal. They are totally different, because I've already given you the differences. Okay, DVM is designed specifically for Android. JVM is designed for each and every operating system which is available. Linux, Windows, Solaris, okay, iOS, like that. We have different operating systems, and JVM is designed specifically for that, but DVM only for one, Android. And it is optimized in two ways, which I've already explained. One, multiple instantiations. Second one, register based. Okay. Now, guys, I'm going to focus on this and tell you the difference. Why I've used the word multiple instantiation. Okay. What about JVM then? JVM has one instance per operating system. Please remember this. Okay. Now, imagine that you are running a servlet, you are running a swing file. Okay. You are running JSP file, JSP servlet, or you're running a swing application separately. Doesn't matter. In your Windows operating system, in your laptop, okay, one JVM is going to get created. And when you run a servlet, that same JVM will be used. When you run a swing application, same JVM will be used. When you write public static void main and write hello world, print system.out.println, core console application using Java, same JVM is going to use. One instance of JVM will be used throughout your operating system. Okay, if you want, just check next time. Run Java program or servlet program using NetBeans or Eclipse or whatever ID you like, and run the program. While running, go to the processes tab, task manager. Go to the task manager and check what is running there. You will find java.exe. One java.exe will be running. Okay, why I'm telling this is, okay, it is not as such as it is going to create multiple instances. Even if you are running servlet or JSP or core application or swing application, whatever using Java, only one instance will be created. One instance of the JVM will be created. But what about my phone? In my phone, each app, when I tap on it and open it, one virtual machine is getting created for each of my app. Please remember that. Okay, each app has its own private copy running in a Linux process. Okay, please remember that, guys. This is very, very important. I'll ask it again and again. Okay, every app runs in its own instance, which means if I am running 4 Java applications in my laptop, one JVM is going to use. If I run 4 apps on my Android phone, 4 DVMs are going to get created. I hope this is synced in. You have understood that. Okay. With that, I'll proceed. I'm repeating it again. If I run 5 applications of Java in my laptop or desktop using Windows or Linux or Mac, doesn't matter. I have only one instance of JVM running in that particular machine. But when it comes to my Android phone, Android app, okay, when I run 5 apps, I have 5 separate DVMs running, Dalvik virtual machines running. Now, you might ask, what is the big difference? Why is that 5 creations or different instances making a difference? Yes, it makes a difference. Why? If 5 applications in my laptop are running, okay, and one of the applications crashed. Okay, please understand this, guys. Imagine 5 applications run on my laptop or desktop, 5 Java applications I'm running. And if one of those applications crashed, okay, most of you would have seen the difference between C, C++ and Java. In C, C++, if you write an infinite loop, your wherever you're running, that C box or DOS box, whatever you're running will crash. It will go to an infinite loop and it will crash. You have to close it and open it once again in order to run the program. Java will never crash like that. The reason is because it's running inside a virtual environment. So if it crashes, it will not crash your application. Rather, it will just crash the virtual machine. Please keep this in mind. So imagine if I'm running 5 applications in one virtual machine of Java. One application crashes, Java virtual machine crashes, restarts again. Very simple. Because you use only one application at a time when it comes to your machine. Probably you'll be using multiple, but you'll just restart as usual. It is nothing new for us. But in an app, okay, in your phone, it is not possible. Like for example, if I've given one virtual machine to all my apps, okay, if my SMS app crashes, all my other apps will crash. But now it is not the case. If some app crashes, it says, unfortunately, this app has stopped. Okay, it will not affect the remaining apps which are running in your phone. But if it follows the original syntax of Java virtual machine, all your apps should crash and restart, which is not a good experience on the phone, right? Okay, so please keep this in mind. DVM is not equal to JVM. Okay, JVM, one instance per machine. Okay, not number of applications does not affect that JVM. But when it comes to DVM, one DVM for every app which is running. So how many apps are running, that many DVMs will run. I hope this is synced in and you have understood this. Okay, let's move on. Small difference between Java, the core Java, what you guys have studied, with Android Java, what we are going to learn this semester. Okay, so I wanted to just go through this diagram, guys. Just look at the diagram. Start with the simple one, the regular Java diagram. You have Java source code. Okay, you compile it, you get Java bytecode, then you run that Java bytecode on Java virtual machine. You get the output. Simple. Okay, I'll repeat that step again. You write a file called Java source code. You write some file name .java. Okay, there is a rule. Okay, I'll talk about the rules and stuff a little bit later in the next class. But there are some rules to be followed when you create a Java file and you save a file name and then you run it. How do you run? How do you compile a program? Command line. Can anybody tell me if the file name is hello.java? How do you compile it? Command. Can you quickly type it? My file name is hello.java. How would you compile it? Quickly. Or you have forgotten? Yes, correct. Java C space file name dot Java. Very good. Okay, that's all. Now, once you do this, what file will be created? Don't tell Java bytecode. I want the physical file name. What file name will get generated when I run this command? Java C space hello.java. Perfect. Okay. No, not Java. Sumana, what she told is right. Sangeeta, you cannot get a Java file again as output. You have compiled a Java file. What you will get? Class. Correct. It will be hello.class. But again, when both of you typed small letter H and the class file name suddenly became capital letter. Probably you're typing it in the phone. Okay, I understand that. But anyway, it should be class file. File name dot class will get generated. Okay, that will be passed to your Java virtual machine. And how do you run and how do you get the output? If you want to see the output, compiling is done. Now I want to run it. What will be the command? To run the program, what will be my command? How do I run this particular file? It's smaller than the previous one. Why is it taking time? Okay. Java space file name. That's all. Okay. Technically, it is Java space class name. You run that and you get the output. Okay. So when you write Java space file name or class name, okay, that Java, the .exe will call the virtual machine, pass this class file and execute it on the Java virtual machine and give you the output. Okay, this is what we typically have seen so far with respect to regular Java. But when it comes to Android, please note, you need not compile, you need not run, all those things will be taken care by the IDE. The Android Studio, what we are going to install, will do all these things. But look at the process. First process is same. You have to write Java code only. That's the only part we are bothered about. Remaining will be taken care by the system, right? So if you're running it through Notepad, you have to do this. But if you're running it in NetBeans, you just need to click on play, start. That's enough. Okay, so here you see Java source code. Okay, you compile it. You get Java bytecode. Very simple. Then comes Dex compiler, Dalvik executable compiler. Okay, which converts it into Dalvik bytecode. And then you run that bytecode on Dalvik virtual machine. Please note the step, guys. This is a little bit more than the regular Java. But you need not do this, system will do it. But look at the procedure and remember it because for theory purposes. Okay, you have Java source code which gets compiled, you get Java bytecode. The first three are same. Okay, then you pass it through something called Dalvik executable, Dex compiler. Dalvik executable compiler, you get the output as Dalvik bytecode. I hope you follow, right? And then simple. Pass it to a Dalvik virtual machine, it will execute and give you the output. That's what is happening right now when you tap on an app and you see it. Okay, Dalvik executable, not your Java bytecode, rather it is Dalvik bytecode. because it has to get converted to run on a Dalvik virtual machine. Okay, please remember this. How do you create an app? How is an app getting created after I write my Java code? This is just a step-by-step mechanism, guys. I'll explain this a little bit more in detail when we start with the program. But just remember, you write Java code. Okay, compile it, you get class, bytecode, Java bytecode. Then you put them through Dalvik executable, text. Okay, and you get Dalvik bytecode, which has the extension as DEX. Okay, Dalvik executable or Dalvik bytecode. All right, and then that is passed into an APK. Okay, using your Android asset packaging tool, it's converted into an APK. Okay, this is setup file. Actually, we are not executing the Dalvik executable when you are creating an APK. When you install this APK on your phone, then whenever you open, after it is installed, then next time you open it, that DEX file gets executed on the Dalvik virtual machine, which is there on your phone. So before I reach your phone, what am I supposed to do? As a developer, you will be writing Java code, will be compiled to a Java bytecode, will be compiled into a Dalvik executable code using a system, then put in that APK. So when I pass this APK to you and you install it in your phone, when you tap on that app again, the Dalvik executable gets loaded onto your Dalvik virtual machine and then you see the output. Simple. Okay, this is the process. All right, and this is just a structure of what are other things available. Apart from the Java code, what you have some other codes also, like music, text, images, the settings of your app, etc., etc. All these things together, you put them inside a .apk file and you pass this only to people to install that app on your phone. Most of you would have done this. When you go to Google Play Store and you install, you don't see an APK file. But if I have an app and I'm sharing it with you, you get a .apk file. Okay, and when you tap on that APK file, you need permission, okay, to install from third-party apps. Okay, when you remove that setting and then you install that app, most of you would have done this in one way or the other. Okay, so that is the APK. This is the procedure. I will explain this once again practically, but this is just the theory part of it. Okay, I will tell you what these things individually mean shortly. Okay, application framework. It is used to simplify the reuse of components. Any application can publish its capabilities and any other application can take that capabilities. Okay, like for example, contacts. That's an app. Please remember that. Contacts is an app, one app. But the data which is available in that contacts app is shared, or the feature which that app has been shared with your SMS app, has been shared with your phone app, the dialing app. Okay, it has been shared with Truecaller, it has been shared with WhatsApp, it has been shared with Telegram. Whichever app asks to access your contacts, you give allow. When you allow, one app's feature is taken into another app. Okay, application framework is designed to simplify that. Okay, to simplify the reuse of components. Okay, so I need not create one contacts app for WhatsApp separately. I can use the inbuilt contacts of my phone and use WhatsApp efficiently. I hope you follow. Okay, it is subject to security constraints. Like for example, you have to ask permission. You cannot directly access the contacts. I'll talk about it more detail later. But remember, this is the idea of a framework. A framework should be able to simplify the complicated and repetitive tasks. Some of you guys are coming from Java Enterprise Edition framework subject. Okay, the reason we have studied those subjects is to simplify our work. In traditional way, it will take a long time, but if I use a framework, I should finish it in a shorter time. Complicated tasks to be completed in simplified manner. That's the idea. Okay, and the tools which are required, I'll stop with this. Okay, the tools which are required for Android, I think this I'll take it in the next class with how to install and what are the things which are required. I'll give you a simple session on this and then we will go to the next class. Okay, so with this I'll stop for today, guys. If you have any questions, please do ask.